Hello and namaste everyone. It's me Krishna Yadav from class 8. Today I am here with the presentation of science subject and today my topic is measurement. But before discussing about my topic I would like to heartily thank our science teacher Mr. Arjun Pokhriyal sir for giving me such a wonderful opportunity to describe a chapter from my science book. And So let's get started to discuss about our topic. Today our topic is measurement, and in the topic measurement we have to discuss on some specific objectives, and those objectives are the objective number one is we should learn to tell the importance of measurement. The second objective of this chapter is define measure fundamental units and derived units, and the third and last objective of this chapter is identify the units of mass, time, and weight in different measurement system. So let's start to discuss about these objectives and focusing on this objective. Let's try to understand this chapter. So first we will discuss about measurement, and we all are familiar about this chapter because we have also read this measurement chapter in class 6 and 7 as well. So we can easily define measurement as the comparison of an unknown physical quantity with non-standard quantity of the same kind. It means if there is any unknown physical quantity, and if we compare those unknown physical quantity with known standard quantity, then that process is that comparison is known as measurement, and the measurement of a physical quantity is expressed in number and its unit. For example, here the mass of a body is 5 kg, and in this sentence we can see that there is 5 kg. This is a measurement, and it is expressed here with the help of quantity and unit. Here 5 is the quantity and kg is the unit of mass. So we must be clear that quantity is expressed in number and its unit as well. The mass of apple is 5 kg. For example, if the mass of 5 kg is mass of apple is 5 kg, then it means that the given mass is 5 times greater than 1 kg mass, which is a standard mass. In this case, the mass of apple is being compared, which is a unknown physical quantity, with the known standard quantity, which is kg and 1 kg. So we can say that the comparison of an unknown physical quantity with known standard quantity of the same kind is known as measurement. Here also we can see that 1 kg mass is the standard unit, standard weight, which is made up of, which is the weight of platinum and iridium metal kept in the International Bureau of Weights and Measures, Paris, France. We know that the General Conference of Weights and Measures, Paris, France, was held in 1960, and in that conference, the scientists designed a standard mass and the standard units for all the measurement. So the 1 kg mass is said as taken as a standard weight, which is the weight of platinum and iridium metal kept in the International Bureau of Weights and Measures, Paris, France. And the weights, the standard mass that we use in our daily life, are the copy of those the cylinder of that platinum and iridium metal. So as we have discussed about what is measurement and it's how it is expressed, let's discuss about its importance in our daily life. Yes, measurement is very important in our daily life. Without measurement, most of the work that we are doing easily, we cannot do that. And measurement also plays a vital role in the economy of the nation. So let's discuss about its the importance of measurement. The very first importance of measurement is that the measurement is essential for buying and selling goods. Yes, if there will be no measurement system, then it will be so difficult to buy and sell goods. It would not be scientific, and the various problems will arise in buying and selling goods. The next importance of measurement is that it is used in the preparation of different food items. Yes, measurement is used in the preparation of different food items. Because if there will not be measurement, then we will not know how much what things we should keep in our food items, or sometimes we can we may give a more unuseful substance in our food than a useful substance. So it is very essential in the preparation of different food items. The main and the next importance of measurement is that it is used to make medicine, insecticides, pesticides, fungicides, etc. Yes, without use of measurement, no any pharmacist can make medicines or any insecticides, pesticides, or fungicides. If the composition of chemicals in medicine is not done properly, then the medicine will not work properly and it will harm our body. So it is very essential to make medicine. So it is very essential that measurement is needed to make medicine, insecticides, and pesticides. The next importance of the measurement is that it is essential for laboratory work. Yes, in laboratory there is too much use of measurement, and many measurement devices are also used in laboratory. If measurement devices are not used in laboratory, then no any work will be possible in the physics, in the physics laboratory, and it will be also be the scientists will also not be able to conduct research. So there are various importance of measurement, and therefore it is given in our book so that we can become familiar with the measurement and use and apply it in our daily life. So now let's discuss about the standard system of measurement. People in different places of our country still use local units like hat, mana, pathi, etc., which are understood by people of certain place only. Yes, nowadays in cities we cannot see like that, but in generally in village and backward areas we can see that there are people are still using local units like hat, mana, pathi, dhakia, dharni, muri, etc. And those measurement system are not understood by every people. They are only understood by certain people, and they are also unscientific also. And those standard system are introduced by local people so for their local users. So it is not a standard, or it is not scientific. We can say that those local units are not scientific or not not a standard. They can vary from place to place and person to person. So in order to maintain the uniformity in measurement, some other standard system of measurement has been introduced. Yes, some other system when in 1960 General Conference of Units and Measures, Paris, France was held. In that conference, many of the standard system of measurement were introduced, and there are four standard system of units in measurement. They are CGS system, MKS system, FPS system, and SI system. So let's first discuss about what is CGS system. The system of units in which length is measured in centimeter, mass is measured in gram, and time is measured in second is called CGS system. We can first of all we should focus on these three words. These three words represent this whole system. C means centimeter, gram means mass, and S means G means gram, and S means second. So these three letters are the units of three different quantities, which are length, mass, and time. So we can easily understand that CS system is the system of units in which length is measured in centimeter, mass is measured in gram, and time is measured in second. So, and the main thing that we remember that CGS system is also known as French system of units. The second standard system of units in measurement is MKS system. The system of and MKS system is taken as the system of units in which where length is measured in meter, mass is measured in kilogram, and time is measured in second. It's called MK system. Just like a CGS system also, we can become clear about the MK system by focusing on these three words, MK and S. Sorry. Here M represents the mass, K represents the kilogram, and S represents the second, which are the units of three different physical quantities, which are length, mass, and time. So in this system also we should focus on the main point, that is it is also called metric system. And the standard system, the MK system also plays vital role in the introducing of SI system. So we will discuss about SI system later, but the main thing in these all the system that we should remember that their short name, like CGS system is also known as French system, MK system is also known as a British system, that metric system. And now let's discuss about FPS system. Like these both system, we can also become clear about FPS system by seeing these three words. Here F represents foot, P represents pound, and S represents second. So here S represents second. So it is also known as FPS system, foot, pound, and second. And the system in which length is measured in foot, mass is measured in pound, and time is measured in second is known as FPS system. It is also known as British system. As MK system is known as metric system, CGS system is known as French system. It is also known as British system of units. So now let's discuss about the fourth and the main standard units in measurement, and that is system SI unit, SI system. SI stands for System International D Units, which is a French word, and we may feel a little bit difficult to remember this word, because here it was introduced in France, so it's full from its System International D Units, which means in our general language international system. So the system of units recommended by the International Convention of Scientists held in France is called SI system. Yes, we know that in 1960 General Conference of Weights and Measures, Paris, France was held, and in that system, the SI system was introduced by scientists to make the measurement, to bring uniformity in the measurement system around the world. And in this system, length is measured in meter, mass is measured in kilogram, and time is measured in second, like MK system. So we can also define the SI system as the extended MKS system is the extended MKS system is known as SI system. So now let's discuss about what are physical quantities, fundamental quantities, derived quantities, and non-physical quantities. First, let's discuss about physical quantities. Those quantities that can be measured and expressed in mathematical form are called physical quantities. Example: length, mass, time, area, volume, etc. We can, from the definition, we can become clear about concept of physical quantities. Physical quantities means those quantities which can be measured, like the length of our body can be measured, which is a length. The mass of our body can be measured. Time can be measured, area can be measured, volume can be measured, but so these quantities are known as physical quantities. And there are two types of physical quantities. They are fundamental quantities and derived quantities. We should not become confused that these both fundamental quantities and derived quantities both can be measured. But the main difference between these quantities is that it is independent quantities, but they are dependent quantities which are dependent upon these fundamental quantities. So let's discuss about fundamental quantities first. Those physical quantities that do not depend on other physical quantities are called fundamental quantities, like length, mass, time, Kelvin, etc. There are a total 7 fundamental quantities which we are going to discuss later, but first of all we have to become clear about the concept of fundamental quantities. And the main thing to remember about fundamental quantities is that these fundamental quantities do not depend on other physical quantities. Like length does not depend on other physical quantities. Mass is also independent. Time is also independent. Kelvin is also independent. Candela is also independent. Mole is also independent. So they are called fundamental quantities. The next thing is that derived quantities. There are two types of physical quantities. We have discussed about fundamental quantities. Now we are going to discuss about derived quantities. So those physical quantities which depend in other physical quantity are called derived quantities. Example: area, volume, pressure, density, etc. Yes, the area is from the definition we can from the example we can be clear about the concept of derived quantities. Area, we know that area, the formula of area is of a rectangle is L square. L into B. It means it is dependent on the fundamental quantity which is length. Like volume, it is the formula of volume of any object. Like pressure, the formula of pressure is force by area. Then from the formula we can say that the pressure is dependent upon force and area. So and the force is pressure is directly proportional to force and inversely proportional to area. So we can say that these quantities are derived quantities because they are dependent in other physical quantities, other fundamental quantities. So it is called derived quantities. Now let's discuss about non-physical quantities. We have previously discussed about physical quantities and its types, but now we are going to discuss about non-physical quantities. What is non-physical quantity? So by seeing this word 3 known, N-O-N, known, we may got some idea about what is non-physical quantities. As we have previously discussed that those quantities which can be measured is known as physical quantity, and simply those quantities which cannot be measured in mathematical form is known as non-physical quantity. Like for example, love cannot be measured, anger can be measured, kindness cannot be measured, and many of the abstract noun cannot be measured. So many of all of the abstract noun are non-physical quantities, and not only abstract noun, all those quantities which cannot be measured in mathematical form are known as non-physical quantities. So let's discuss about units. Now let's discuss about what is unit. Units are the fixed quantity of measurement. Units are the fixed quantity of measurement, and unknown physical quantities are compared with the known standard quantity which is known as unit and expressed in terms of units. For example, there is there is two apples, and those two apples are compared with a standard mass which is 1 kilogram, and that standard mass 1 kg is known as units. So those unknown physical quantities, those two apples are compared with a known standard quantity kg unit, and then after that they are expressed in terms of the units. There are mainly two types of units. There are fundamental units and derived units. The main thing to remember here is that quantities and units are two different things. There are also two types of quantity and two types of units also. Fundamental quantities and derived quantities, and units are also there two types: fundamental units and derived units. So let's discuss about let's discuss about fundamental unit and derived unit. But first we should let's discuss about fundamental unit. Those units which do not depend on other units are called fundamental units. For example, meter, kilogram, second. All the units of the fundamental quantities are fundamental units. For example, here we can see that length is fundamental quantity, mass is fundamental quantity, time is fundamental quantity, temperature is fundamental quantity, current is fundamental quantity, luminous intensity is fundamental quantity, amount of substance is fundamental quantities, and all the units of these fundamental quantities are fundamental units. For example, the SI unit of length is meter, SI unit of mass is kilogram, SI unit of time is second, SI unit of temperature is Kelvin, SI unit of current is ampere, SI unit of luminous intensity is candela, SI unit of amount of substance is mole. So, and these kg, s, k, ampere, cd, mol, dot, these all are the symbol of these units. All those units in the physics have its own symbol or its own specific symbol. So we must remember that all the fundamental quantity have its units, and all the units of fundamental quantities are known as fundamental units. So now let's discuss about derived units. Those units which are formed by the combination of fundamental units are called derived units. Some of the we have previously discussed about fundamental units, and from the definition we can be clear that what is derived units. Derived units are those units which are formed by the combination of fundamental units. Here we can see that here there are physical quantities, and these physical quantities are derived physical quantities. Derived physical quantities means we have discussed that those quantities which depend on fundamental quantities. The main thing to be to understand in these both fundamental units and derived units are is that all the units of fundamental quantities are fundamental units, and all the units of derived quantities are derived units. For example, here we can see that area is a derived unit, volume, density, speed, velocity, acceleration, force, energy, work, power, pressure, these all are the derived quantities, and the units of these derived quantities are also derived units. For example, here the unit of area is square meter, the unit of volume is cubic meter, the unit of density is kg per meter cube, the unit of speed and velocity is meter per second, the unit of acceleration is meter per second square, the SI unit of force is Newton, work and energy it is joule, the SI unit of power is watt, the SI unit of pressure is pascal, and we have discussed previously that all the units have its own specific symbol like that. Here we can see that the symbol of a square meter is meter, and exponential means power 2d2, m to the power 2, and like that here m to the power 3, kg per meter to the power 3. These all are the symbol of these units. So we can be clear about these that derived unit are those units which are formed by the combination of fundamental units, and the fundamental units are those units which are the units of fundamental quantities, and derived units are those units which are the units of derived quantities. So these are the two main things that we should remember. Now let's discuss about measurement of weight and what is weight. So many of us may have questioned that if we throw a body towards the sky, it falls down towards the earth after some time. Why? While playing also, if we throw a ball or any stone, any bat, anything, any book, any copy, anything toward the sky, after a certain time it comes down to the earth's surface. And the reason behind is that the falling of those objects is that the earth attracts any object towards its center. So any object thrown off always returns in the earth's surface. And from this sentence we can get the answer why. Why? Because the earth attracts any object towards its center due to its force, gravity. And here the earth attracts any object towards its center, and it attracts all the object towards its center due to its special force which is known as gravity. And due to the same attraction, the fruit falls of the tree, rain, water, snow, hail, etc. also falls down due to the earth's surface. And these all activities happens due to the force of attraction of the earth, which is known as gravity. The gravity acting upon a body is called its weight. Here many of the students may become confused about gravity and gravitational force. So let's discuss what is difference between gravity and gravitational force. Gravity is the force of attraction of earth, but the gravitational force is quite different thing. It is the force acting between any two bodies due to their masses. For example, there is gravity in earth, but the earth is revolving around the sun due to gravitational force. So we should not become confused in the gravity and gravitational force. So now let's discuss about weight. We have discussed about some fundamental things that we should know before learning about weight. Now let's discuss about weight. The force by which an object is attracted toward the center of the earth is called weight. Weight is a kind of force, so it is measured by a spring balance. We have previously discussed that the force by which an object is attracted towards the center of the earth is called weight. Weight, we can also define weight as the gravity acting upon a body. Gravity acting upon a body. Why? Because the force by which an object is attracted toward the center is known as gravity. So we can easily define weight as the force, the gravity acting upon a body. And weight is a kind of force. Yes, weight is a kind of force because weight is a force which is the force which is a force by which an object is attracted toward the center of the earth, and so it is measured by a spring balance. It is not measured by beam balance. We know that in our general sense we say that the weight of potato is 1 kg, but it's not actually 1 kg. It is 9.8 Newton. But due to our general use, we have a concept that the weight of apple is the weight of apple is 1 kg, but it's actually its mass. It is not its weight. So the acceleration of the acceleration produced on a body when it falls down from a certain height is called the acceleration due to gravity. Yes, this is the main thing that we should know before discussing about weight and to understand the concept of weight. The acceleration produced on a body when it falls down from a certain height is called the acceleration due to gravity. The acceleration due to gravity is caused due to gravity because gravity is a force which pulls all the object towards the center of the earth. And while pulling the center of the earth, the speed of the object gets increasing by 9.8 meters per second, which is also the gravity, which is also the gravity of Earth. And that the acceleration which is produced when a body is being pulled toward the surface of the earth due to gravity is known as acceleration due to gravity. The weight is equal to the product of mass of a body and acceleration due to gravity on that place. So we can, from this sentence we can easily derive the formula of the weight. If in the question it is said that the mass of apple Vishal is carrying a mass of 5 kg and then calculate its weight. Then if we know that the standard gravity of the earth is 9.8 meters per second and the mass which Vishal is carrying is 5 kg, then we can easily multiply the mass and the acceleration standard gravity, that is 9.8 meter per second square, and we can easily find the weight. So now let's discuss about difference between mass and weight, which is a very essential things to understand in this chapter, because many of us are confused. Many of the students are confused in the mass and weight. And in the first term examination also there was a question to differentiate between mass and weight. So let's discuss about it seriously. The mass and weight are quite different things, but due to our day-to-day life, we have become familiar with the concept that the weight of apple is 1 kg, but it's actually its mass, and the weight of the 1 kg apple is 9.8 Newton. So now let's focus on the differences between these two things. The quantity of matter contained in a body is called mass. Yes, the quantity, it means the amount of matter which is present in a body is called its mass. But the weight is the force of gravity of the earth acting upon a body. Yes, we have previously discussed that. Weight is the force of gravity of the earth acting upon a body. When the force of gravity acts upon a body, then that force is known as weight. And the formula of weight is we have then And we also know the formula of weight, which is mass into acceleration due to gravity. The second difference is that mass is constant everywhere in the world. Whether we are in the earth, whether we are in Nepal or moon, whether we are in Nepal or Japan, whether we are in Mars or Jupiter or Uranus or Neptune, it does not affect the mass of the body. It is constant everywhere in the universe. But weight is variable from place to place. Yes, we have previously discussed that weight is the force of gravity of the earth acting upon a body, and the gravity of different places is different. So it varies from place to place. The next difference between mass and weight is that mass is measured with the help of beam balance, but it is measured weight is measured with the help of spring balance. Mass is used to beam balance is used to measure the mass of the body, but the way the spring balance is used to measure the weight of the body. In the shop also, if you go and say that give me 1 kg of apple, then it is our concept. So it is the according to the us it is right, but in the scientific way it is wrong, because that 1 kg apple which is measured with the beam balance, it is its mass, not its weight. And if it was measured with the help of spring balance, then the weight of 1 kg apple becomes 9.m Newton. So this is the main thing that we should remember, and we should keep in mind in our daily life. And it's as they are quite different quantities. Their assignments are also different. The assignment of mass is kg and the assignment of weight is Newton, because the assignment of force is Newton and weight is also a kind of force. The very main thing, the most important thing that we should remember, that note that 1 kg mass is equal to 9.8 Newton at sea level. Because as it is here, the main thing is sea level. As the height goes on increasing, then the gravity goes on decreasing, and when the gravity decreases, the weight also decreases. So this is the main thing that we should consider, that 1 kg mass is equal to 9.1. The weight of 1 kg mass at sea level is 9.8 Newton. We should not become confused in that, and we should be fully clear about mass and weight, which will also help us in our day life. Now let's discuss about time and measurement of time. The interval between any two events is called time. For example, it took me 5 minutes to come home from school. It is the duration between two events. From coming from school to reaching the house, it is these two things are two events, and the interval between the time which is consumed between these two, the things which is consumed between these two events is known as time. And here when I say that it took me 5 minutes to reach home from school, it is time. The unit of time is determined on the basis of time taken by the Earth to rotate about its axis. Yes, it is the main thing. We know that the Earth does two types of rotation. It also the Earth moves in two ways. By rotating also and by revolving also. The Earth rotates in its axis, which causes day and night. And when the Earth revolves around the Sun, it causes season change. So we must be clear about the rotation and revolution of the Earth in its axis and in its orbit. So the unit of time is determined on the basis of the time taken by Earth to rotate about its axis, not the time taken by the Earth to revolve around its orbit. The time taken by the Earth to complete one rotation about its axis is called the solar day. We know that as we have discussed that Earth moves by two ways, by rotating and revolving both. Then it is clearly said that here the time taken by Earth to complete one rotation, not revolution. One rotation about its axis is called known as solar day. And when we divide a solar day into 24 equal parts, 24 equal parts, we must remember this quantity 24. 24 equal parts. Then each part will be known. Each part is known as 1 hour. Similarly, if we divide 1 hour into 60 equal parts, then it becomes 1 minute. And similarly, if we divide 1 minute into 60 equal parts, it becomes 1 second. Here, the main thing that we should remember here that there is 24, 60 and 60. If a day is divided into 24 equal parts, then it becomes 1 hour. If 1 hour is divided into 60 equal parts, it becomes 1 minute. And if 1 minute is divided into 60 equal parts, it becomes 1 second. Here we can also see that 1 day is equal to 1 hour. It means one solar day has 24 hours, and 24 hours has 24 into 60. Here if we divide 24 into 60 equal parts, then it becomes 1 minute. So 24 into 60, 24 hour or 1 day has 1440 minutes. Similarly, 1440 minutes has 86,400 seconds, or 24 hours has 86,400 seconds, or you can also say that a solar day has 86,400 seconds. These all things are similar things. Therefore, we must remember that a day has 86,400 seconds. And now we should we have learned that there are 86,400 seconds in a day. But now let's discuss about what is 1 second. 1 second. It is a very few time. It is a time in which we can also not blink our eyes. But in the physics, it is defined as the 1 by 86,400 part of the day. Yes, here in this equation we can see that there are 86,400 seconds in a day, and if we take one part of 86,400 second part of 1 day, then it becomes 1 second. So we should not. It is the most important thing that we remember in the measurement of time. Now let's discuss about the instrument which is used to measure time, and we are very familiar with that instrument, and its name is watch. Watch is a scientific device which is used to measure time. We all must have seen watch and used it also. So there are different types of watches used to measure the time, such as the simple watch that we use, digital watch, atomic watch, etc. In our daily life, simple watch are used, in which a few seconds may fluctuate from the exact time. But the scientists use atomic watch to measure the accurate time. It is said that in 4 billion years, the atomic watch fluctuates only 1 second. We can imagine how much accurate that atomic watch is. And it is also necessary that the watch that scientists use should be very accurate, because in scientific work, the 1 second also kind of cause a huge damage to a whole project. So scientists use atomic watch to measure the time very accurately. Now we have discussed about all the topics. Now let's discuss about the summary of these topics. What are the things that we know after the completion of those topics? The first thing that we should know is that the quantities which can be measured are called physical quantities. The physical quantities are the quantities which can be measured. We should not remember these whole things. We should only remember about the concept. Those quantities which can be measured is known as physical quantities. Those quantities which cannot be measured are known as non-physical quantities. The second thing that we know is we should know that the physical quantities which are independent of each other are called fundamental quantities, and the physical quantities which depend on fundamental quantities are derived quantities. I have said this thing many times, that we should not become confused in these two things: fundamental quantities and derived quantities. The fundamental quantities are those quantities. The physical quantities are those quantities which can be measured, and there are two types of physical quantities. There are fundamental quantities and derived quantities. The fundamental quantities are those quantities which are independent of each other, but derived quantities are those quantities which are depend on other fundamental quantities. The next thing that we remember is that measurement means the comparison of an unknown physical quantity with a known standard quantities. This is the most important definition that we should remember till class 10 or plus 2 also. So we should keep this definition in our mind and try to remember it. The fifth thing to remember things, the fifth thing to know that from the thought objective is the units which are independent of each other are called fundamental units. The units which are independent of each other are called fundamental units, and the units which are depend on other fundamental units are derived units. Like there are two types of physical quantities. There are also two types of units. There are fundamental units and derived units. Fundamental units are independent, but derived quantities depend on other fundamental units. The the seventh the seventh thing to remember in this from the thought objective is that there are four standard system of units, which is a CCS system, MK system, and FPS system, and SI system. The eighth thing to remember from the thought objective is the system of units recommended by the International Convention of scientists held in Paris, France in 1960 is called SI unit. Yes, SI unit is the main thing that we should learn before reading the physics. If you don't know about SI units, we may get 0 mark in physics because it is its basic thing. And here we should also remember this date 1960. This is the day. This is the year which brought a very huge change in the measurement system of the world and led the world in the way of peace, prosperity and advancement. The ninth thing to remember is that the force of gravity applied on a body is called its weight, and the weight is measured by the help of spring balance. Weight is measured with the help of spring balance, and mass is measured with the help of beam balance. The 10th thing that we should remember is that the amount of matter present in a body is called mass, and we should also remember and try to learn the difference between weight and mass, because it creates a huge problem when we go in upper classes. And the last thing that we should remember is that the duration between any two events is known as time. These are the summary of the third chapter which we should all should try to learn and remember. Thank you for watching. Stay home, stay safe. If I have done any mistake, then sorry for that. Wishing you a happy Diwali and Chhath. I would like to end my topic here. Thank you.